In the working dog world, there is a pervasive assumption. A dog shadowing its handler's every move indicates a strong bond. That hypervigilance is actually an inability to self-regulate stress. Clinically, this behavior is classified as an insecure ambivalent attachment. A biologically secure domestic dog does not need constant physical proximity. It possesses the emotional capacity to maintain distance. While an anxious dog remains paralyzed by the handler's absence, a securely attached dog feels safe enough to focus intensely on independent tasks. Domestic dogs form quantifiable biological attachment bonds identical to human infants. The definitive proof of that bond is independence, not dependence. To measure this relationship accurately, we must discard emotional anecdotes and test the animal's physical cognitive capacity when separated from its handler. The empirical measurement of attachment did not begin with canines. It originated in human developmental psychology. In the 1970s, psychologist Mary Ainsworth built a framework to categorize exactly how infants attach to their caregivers. She designed the strange situation procedure, a controlled, mild stress test involving a stranger and a brief caregiver separation, intended to trigger and measure raw attachment behaviors. Decades later, researchers adapted this exact procedure for canines, standardizing the introduction of a stranger and a handler separation to observe the dog's responses. This grid maps the resulting canine data. The baseline split shows 61% of dogs classifying as secure and 39% as insecure, a distribution that precisely mirrors human toddler populations. The 39% insecure category breaks down into two primary subtypes: ambivalent dogs that cannot self-soothe, and avoidant dogs that suppress their distress entirely. The 61% secure category expands to reveal all four ethological hallmarks of attachment: proximity maintenance, separation distress, using the handler as a safe haven, and operating from a secure base. Canine attachment is a statistically verifiable psychological structure identical to human development. These behavioral observations are driven by specific underlying endocrinology. During the strange situation procedure, researchers track cortisol, the primary stress hormone, to see exactly how the canine nervous system reacts. This line graph plots cortisol levels over time. In a social test, the secure dog's cortisol drops and stabilizes upon reunion with the owner, showing effective self-regulation. The insecure dog produces a vastly different physiological response. Their cortisol remains elevated and fails to return to baseline after the reunion. But if we expose these animals to a threat scenario without the owner present, the data flips. The secure dog's cortisol spikes severely, soaring higher than the insecure dog's baseline. This physiological paradox occurs because the isolated secure dog relies exclusively on that specific human to regulate its emotions. Without them, the dog absorbs the full impact of the stress. This regulatory affiliation between species is stabilized by a neurochemical mechanism called the oxytocin gaze loop. Mutual eye contact between a dog and its handler triggers endogenous oxytocin release in both brains. This hormone physically lowers the heart rate and enables the secure base effect. A secure bond is a shared physiological network. The human's presence acts as a biological thermostat, directly controlling the temperature of the dog's nervous system. Because the human acts as the thermostat, the handler's specific behavioral style directly dictates the dog's physiological outcome. Consider authoritarian handling. This approach relies heavily on high owner control, intrusive physical manipulation, and forced rigid compliance. This flowchart demonstrates the results. Invasive handling creates an insecure avoidant attachment pattern, forcing the animal into passive coping mechanisms and suppressed exploration. By contrast, sensitive handling prioritizes providing support while allowing the dog the autonomy to process its environment independently, leading to secure attachment and active engagement. This autonomy dictates performance. The data shows that responsive care consistently correlates with the highest rates of active problem-solving and environmental resilience in test subjects. Micromanaging a dog's behavior achieves superficial compliance, but the data suggests it comes at the cost of the neurochemical stability needed for complex processing. That capacity for advanced learning points to the ultimate evolutionary advantage of a secure attachment: increased cognitive throughput. The biological economics are straightforward. When a nervous system is freed from chronic cortisol management, it generates excess bandwidth to process abstract environmental data. A recent study examining gifted word learner dogs provides empirical proof of this cognitive surplus at work. Confident dogs were exposed to novel toys entirely by eavesdropping on human conversation, with no direct interaction or deliberate training involved. This bar chart compares the retention data. The dogs retrieved novel toys they only passively overheard with 80% accuracy, making the difference from direct teaching statistically negligible. Typical family dogs completely fail this test. Eavesdropping is a specialized capacity researchers find only in specific, highly secure cognitive profiles. This kind of passive vocabulary acquisition mirrors the developmental milestones of 18-month-old human infants, who learn through the exact same background observation. The secure base effect is the direct biological prerequisite that allows a dog's brain to successfully decode and acquire human language. The human-dog bond is not a romantic metaphor. It is a highly evolved survival mechanism that predates language itself. Sensitive handling enables endogenous oxytocin regulation. That regulation lowers cortisol, and the resulting calm nervous system provides the bandwidth for cognitive persistence. The flexible tether of a secure attachment empowers an animal. The rigid chains of dependence and forced control only restrict it. For working dog trainers and behaviorists, the data demands a shift in methodology. To build maximum operational capacity in an animal, you must optimize for responsiveness, not blind compliance. The ultimate goal of a secure bond isn't keeping a dog by your side, but becoming the base they confidently leave.